All right, this is the 9-1 practice question number 2. The diameter of a spindle on a small motor made for the Ford Explorer fan system is supposed to be 5 millimeters. Whenever you see that word supposed to, folks, it is telling you what the null hypothesis is. This is going to be mu. Then it tells us that it has a sigma of 0.04. There's a lot to take away from this. Sigma is the population standard deviation, population SD. Because of that, this will be a z-test whenever you have the population standard deviation. I'll tell kids this little memory trick. Use the word zopulation to remember that if you have the population standard deviation, it's a z-test. So zopulation, putting those two things together. Anyway, if the spindle is too large or too small, the motor will not perform properly. The manufacturer measures the diameter in a sample of 43. So there is N right there, sample size, 43, and finds the average to be 5.04. So that would be the result of my sample. That would be X bar. That would be the statistic. Does the manufacturer have significant evidence at the 0.01 level, alpha 0.01, that the shipment motors is defective? All right, the population is just all the spindles that are made for Ford Explorers. And there are hundreds of thousands of those on the road, okay? The parameter that's being measured is the actual diameter. I should say that it is the average diameter, the mean diameter of a spindle, okay? And the general equation that we will be using is we will be getting a z-score using x bar, subtracting mu, and dividing by the standard deviation of a sample of this size. So that's the formula. All right, let's dive into HYTAPSE. Remember, HY is for the hypotheses. So the null is, we already talked about it up here in green. It's what is supposed to be true for all of these, that mu will be 5. The alternative now is that mu is going to be what? Is it going to be less than, greater than, or not equal to? Is there anything in here as we read that suggests we would lean one way or the other? And it just says, do we have evidence that the shipment is defective? It doesn't say that they're too big or too small. So I think this would be a two-sided or a not equal to, okay? Just not equal to 5. The name of the test is a one sample z-test, okay? The assumptions, A. 1, is it random? Let's see, did it actually say it was random? It just says in a sample. So I would say not stated. Proceed with caution. I don't think I'm missing anything up there that says. Yeah, it doesn't say anything about it really being random. Number 2, is it approximately normal? Now remember, when we are doing a sample mean, because we're doing an average, we're doing a mu, right? This is the central limit theorem, CLT. So and our sample size is 43, and that is big enough. 43 is greater than 30, so we're good. Okay. Number 3, is it independent? You could just say generically that like the diameter of one spindle is independent of the diameter of another spindle. If you want to do the 10% rule, You take 10 times the sample size, 10 times 43, that's 430. Um, so is that less than the population? And we talked about the population up here. This is all the spindles that have been ever made for all Ford Explorers. So yes, that is definitely true. All right, so that's T test, A assumptions. P is do the work, get the P value. Let's just do right here. So what is my Z going to be? X bar is the average of the sample, 5.04. Mu is 5. I'm just grabbing those from right here and right here. Divided by the sigma, which they gave us in red, 0.04, and it will be made smaller because our sample is not a sample of 1, it was a sample of 43. Okay, now if you take your time and put that in the calculator, you will get 6.55. This is called the test statistic, folks. Okay, so maybe a slightly new term for you. This is the number of z-scores. This is crazy. What this means, you guys, is like if 5 is the truth, the probability of getting the sample over here at 5.04, like 5.04, 5.04 or greater, is the z-score of that would be 6.55. Remember, the z-score in the middle is 0. This would be 6.55. I just had a brain fart, or realized I had a brain fart. 5.04 is greater than 5. So I think I'm going to retract my statement here about the double, the two-sided. Since my sample average is greater than 5, I think I'm going to put a greater than sign in there and make this a one-sided test. So as I drew this diagram, it helped me realize what I should put right here. Okay, so I got my z-score. I now need to get my p-value. My p-value can be gotten from looking in my formula sheet for 6.055. And as I'm looking at table A here, for 6.05, I realize the farthest it goes is 3.5. Uh-oh. So what does that mean? Essentially, it means I have 100% of the data will be lower than this point. In other words, this yellow shaded area would be like 100%, which means this has a p-value of 0. I'm going to put approximately 0. Okay, so I can also get that p-value on the calculator. After I've shown my work, right, I can also do the test on the calculator. So I'm going to look for stat tests. Yours might not say this like mine does, but one sample z-test. If you look at number 1, it says z-test in bold, but underneath it, it says one sample z-test. So number 1. And let's put in what they gave us. The null, mu, was 5. Sigma was 0.04. X bar was 5.04. N was 43. There, see, so there's your Z. Same thing I got, 6.55. And look at that p-value. Now, when you first see it, you might think the p-value, um, you might think, well, why it's 2.75, not 0. But don't forget, it has times 10 to the negative 11, right? Which means it's essentially 0. You'd move that decimal 11 places that way, so it would be 0. Um, and I do have the greater than selected. If I had the less than selected, it just shades the other side. And notice the probability, the P is 1. All right, so then I need to make my conclusion. Oop, go away, calculator. So with C for conclusion, with P of approximately 0, which is way less than alpha. Remember, alpha was 0.01, right? we will, remember our little cheat thing here, not cheat thing, little diagram, put 1 at the top, 0 here. Our alpha is 0.01, and so 0 comes in way underneath here. If we're up here, we failed to reject the null. Okay. And if we are down here, we reject the null hypothesis. So we are firmly underneath alpha because we pretty much got a probability of 0, a p-value of 0. So with p of about 0, which is less than alpha, we will reject the null hypothesis and say there is convincing evidence that the mean width, or not width, diameter, kind of the same thing, of spindles in Ford Explorer fans is greater than 5 millimeters. All right. D, based on the conclusion above, what type of error or mistake could we have made? So what did we do? We rejected the null, so that could lead to a type 1 error, which is when the null is actually true. So what type? You say type 1, and it says, what's the consequence? So we claim the spindles are too big, right? We're rejecting that they're 5. We're saying that they're bigger than 5. We're saying they're too big, but in reality, mu does equal 5. Think practically, what is this? This would be a problem for Ford, right? Ford, somebody would do this experiment, this research. They'd tell Ford, your spindles are too big. Ford would say, uh-oh, and they'd maybe change their production line and go through a lot of time and money to fix it, and it doesn't even need to be fixed. So that would be a bad thing. Would the power be high or low? Well, it's going to be quite high, okay, because I got such a low p-value. Remember, power is the probability of correctly rejecting the null. And when I get a p-value that is so low, I am very confident that I am correctly rejecting the null. So I would say it's like 99%. Okay. The probability of a type 1 error, remember, is alpha, which is 0.01. Because that alpha is set by the researcher, everybody. So if you put it at 1%, then you are saying, I'm willing to set the mark at 1% where any samples that occur less likely than 1% of the time, those samples I will use to reject the null. Because remember, how do you interpret the p-value? It is if 5 is the truth, if 5 is the average of all the spindles, then a sample like ours will randomly occur, well, 0% of the time. But like say it was a 1%. If 5 is the truth, this sample will occur randomly 1% of the time, even when 5 is the truth. So that maybe helps you understand why the probability of a type 1 error is whatever alpha is set to be. Probability of a type 2 error is 1 minus the power. So 1 minus 0.99. I put this as 0.99. So a 1% as well. probability of type 2, remember, is this. So if this box was a 99% error, then this box is a 1%. Okay? Um, these go hand in hand when you're talking about power and the probability of a type 2 error. All right, that's all.